So far we have talked a lot about proportionality, how to find the constant of proportionality, how do we find out those things that are related, then write the equation. Today we are going to specifically talk about what if they are not proportional? How do I know? So let's remind ourselves of some things. To be proportional, okay, the constant of proportionality, or y divided by x, needs to be the same for all points. Okay, that has to be true. The equation will look like y equals kx. And for a graph, it will be a straight line and go through the origin, or that is the point 0, 0. Okay, so all of those things must be true for this to be proportional, and it can be interchanged. So looking at this one, okay, so it is a straight line. We're talking about two different gym memberships. So this one is a straight line, but does not go through the origin. So let's write that down. But not through the origin. So it's a straight line, but it does not meet this criteria. So this graph is non-proportional. All right, this one at Fit for Life, the number of visits compared to the total cost, it is a straight line and it does go through the origin. So let's jot that down. So because it meets both of those criteria, this example is proportional. So what are some things that are similar and what are some things that are different? Well, this one is fitness connection. Okay, things that they have in common is that they are both straight lines. Let me make sure I said it the way I want to say it. Okay. But what they have that's different is that only Fit for Life goes through the origin. So to be proportional, it has to be a straight line and go through the origin. All right, so what I've done here is I have just pulled points from those graphs, and we are going to check of whether or not they are proportional. Okay. So let's write y over x, and we're going to double check just to kind of see what it looks like for a table to not be proportional or what it looks like for the table to be proportional. Okay, so the number of visits is the x value, and the total cost is our y-axis, so that's our y. So visits is x, total cost is y. So I'm going to check those points and divide them and see if I get the same unit rate every time. So here I'm going to take my y value 20. Let me get easier hard. That makes it much harder for y'all to see that calculator. Let me brighten that up. So I'm going to take my y value 20. Actually, let's start with here. We're going to do 30 divided by 1 is 30. So I'm going to jot that down here. 40 divided by 2 is 20. The y value 50 divided by its x value of 3 is 16. We'll do 16.6. And then my y value of 60 divided by the x value of 4 is 15. So I can see that the unit rate, okay, is not the same for fitness connection. Now I'm going to go check fit for life. I'm going to take the y value, 10, divided by the x value of 1. 10 divided by 1 is 10. I'm going to take the y value of 20, divided by its x value of 2. 20 divided by 2 is 10. 30 divided by 3 is 10. 40 divided by 4 is also 10. So the thing that is different about them is that at fitness connection, does not have a constant unit rate. Fit for life does have that constant unit rate, okay? So just like the graphs, they were similar, right? They were both straight lines, but one of them is proportional, the other is not. All right, so let's summarize some things up here, okay? So I'm going to have us add some things to this, but non-proportional relationships. It says a relationship between two quantities is non-proportional if the ratio between the two quantities is not constant. Okay, and let's make a note to ourselves that is y divided by x. To be proportional, y divided by x needs to be the same thing every single time. Okay, so the graph of a non-proportional relationship will not pass through the origin and it may not be a straight line. Let's add that. And then we're going to skip these two down here. Okay, then at the top, I want you to include that the equation so a non-proportional equation might look something like y equals 3x plus 7. If I am adding or subtracting something on the end, it is not proportional. Right, and that is it. So if, let's add it to the bottom, just, for repetition. We're going to just use this space. So to be proportional, y divided by x is the same for all points. Okay. The equation will look like y equals kx, just that. The graph will be, we're going to have to squeeze this in, a straight line through the origin. We'll say 0, 0. Okay. So at the top, we have what does it look like if it is not proportional. At the bottom, we've made a note of What if it is proportional? What should it look like?